It is natural to ask what soils are the most productive. It's just a very natural question because it determines where we can get the most resource for our investments. In general, soils need to have enough water holding capacity, and they need to have enough nutrients such that those two factors become less limiting to growth. And that does happen in many parts of the globe. So water holding capacity is oftentimes, is typically a function of two factors. One, the texture of the soil, its capacity to retain water by having clay particles, and also being able to drain such that there is enough oxygen penetration into the soil. And that typically is controlled by sand content. So too sandy of a soil will drain too quickly, it won't hold water. Too much clay won't drain at all, and both are a problem. Soils need to have sufficient levels of nutrients. Nitrogen, phosphorus, and potassium are the most common, and soils need to have a healthy soil microbial community to help foster turnover of those materials. Soil organic matter is important for both water retention and water holding capacity as well as nutrients. Organic matter is like a sponge that holds on to water, it retains it and doesn't hold it too tight, and it's also the main reservoir of inorganic nutrients in soils. We'll talk about it more. So what are we talking about when we say nutrients? Typically, like I say, NPK and also calcium. Nitrogen is the main constituent of proteins. Phosphorus is essential for nucleic acids, as well as storing molecular energy in the form of ATP and associated compounds. Potassium controls osmotic gradients, and calcium also is important for a number of reasons, including osmotic gradients and cell wall formations. There are other nutrients that are important, that can be limiting, but they are needed in much smaller quantities. In commercial products, commercial fertilizers oftentimes have a suite of these compounds, these elements. In general, they will have more nitrogen and phosphorus and potassium because those are needed in greater amounts and tend to be more limiting than the others. These commercial products work because adding nutrients typically increases growth. Now, about soil carbon, there's a lot of it. It's important as a nutrient reservoir. Much of it is biologically available, and it can be in very high concentrations, for example, in grasslands. It's also in very high concentrations in the Arctic, these gelisols, kind of exotic soils that are underlaid by permafrost. But in that case, the material is frozen and it is not biologically available. One other point to make here, and that's a big part of the article that we read for this week from Bigelow and Canham. The authors show that many limiting soil nutrients in eastern deciduous forests are influenced by the chemical characteristics of the soil, pH. Some of these limiting nutrients are more available at high pHs, some are more available at low pHs. The point being here, changing the pH of the soil influences what nutrients are available, and that has an outcome in terms of what species are dominant where. So if you're trying to grow sugar maple, because it's a very valuable tree that's very valuable as veneer, and of course you can make maple syrup from it. You want to know what the pH is, and maybe even might want to try to manipulate it in some way. Likewise, it's helpful to know where where species with maybe a bit lower economic values, such as beech, would be located, so that you could think about what you want to do within those stands. Here, in this case, soil nutrients matter. They're determining where these individual species are occurring on the landscape. And that's really helpful to know. Now, soil nutrients also limit productivity of forests nearer to us, and if you've visited serpentine soils, you've seen this. On West Cuesta, there's a great example of forest growing on these ultramafic outcrops, and these soils have very low nitrogen, phosphorus, and calcium availability within them. They also tend to be thin, which means that they just don't have much soil to hold on to water. It can be a very difficult place to live, and serpentine soils are in no way the most productive ecosystems around, but they are interesting and valuable because of the biodiversity that they hold. It is extremely challenging to grow in a soil that is so, where everything is working against you in terms of productivity. But yet, these low productivity soils have value because the things that can persist there, it's such a unique place. Much of our biodiversity is contained within them.